What out of thin air, it's something people still think it's not possible, or it's still like something out of science fiction. One other reason why we're looking at air as a resource, because water vapor in the air is almost 6 times the water we have in all the world's rivers combined.
So basically, NASA's research on Mars led to you developing actually the same thing on Earth.
Yeah, you could say. And
Elon Musk talks a lot about Mars, and he has also talked about the concept of actually nuking Mars poles.
But the basic concept is that he wants to terraform the whole planet. I get a lot of inspiration from science fiction as well. So if you have seen Star Wars, there have been moisture evaporators on all across the entire universe. We kind of went a bit crazy. We proposed that you can have hot air balloon kind of structures which are floating in the sky and drawing moisture, and there's a pipe from the sky to your house. You're working on water, which people don't really want to fund or don't see that as a problem. Second, you're also making hardware. And third was, you don't get that support from your friends and family. Also, if compared to this, say you're making something which is growing fast, and it's visibly growing fast.
पता है आज के एंटरप्रेन्योर ने कर दिखाया है एक अजूबा जादूगर। इस एंटरप्रेन्योर ने क्या किया? इस एंटरप्रेन्योर ने बना दिया पानी हवा से पानी। लिटरली ऐसा पॉसिबल है? साइंस फिक्शन तो नहीं है ये। वेल, हेलो एवरीबॉडी, वेलकम बैक टू अनदर अमेजिंग एपिसोड ऑफ द क्लाइमप्रेन्योर शो। आज पॉडकास्ट पे हमारे साथ हैं स्वप्निल, एन अमेजिंग एंटरप्रेन्योर। इंडिया फेस ह्यूज वाटर क्राइसिस एंड देयर आर मिलियंस ऑफ पीपल इन इंडिया हु आर लिविंग इन वाटर स्ट्रेस. And this entrepreneur today has come who is actually making water from air. And doing this, he's also actually helping to save the groundwater. While this sounds like an amazing idea, I also went wow, Swapnil, how could you do this? But what did it actually take to turn this intriguing, amazing idea into a startup, into a business? What did it take to build the right team? What did it actually take for him to find the right product market fit? It took a Siddhi Dil to actually be on this journey. The journey was not easy for Swapnil. The journey is not easy for Swapnil. But he is doing it, he's pursuing, and as he says that being an entrepreneur, if there is even a single strand of hope left, you cling to it. So let's hear it from Swapnil. Let's hear it how did, with his resilience, with his courage, with his ability, with his passion to do something, he today is helping to solve water stress for millions of Indians. Let's go straight into the conversation. Do not forget to hit the subscribe button. So, welcome Swapnil on the Climapreneur show. I'm excited to have you here. And that idea कि ये इंसान हवा से पानी बना रहा है, that is so interesting to me.
So first of all, Shweta, thank you so much for having me. And I'm really glad that I'm able to, get on with you and speak.
Did you, frankly, had any other option apart from not being glad? So, Swapnil, हवा से पानी बना रहे हो आप, where did this idea even came from? And obviously, when you go out and tell people that what do, you say I'm making water from air. What are the initial responses?
So I think the most basic response is people get excited. Okay.
They think that you're crazy?
No, I used to get that a few years back. Is this something really possible? And why are you even doing this? There's no problem with water or things like that. But I think people now see it more okay, this is quite innovative, it's exciting, and it does catch their attention. So water out of thin air, it's something people still think it's not possible, or it's still something out of science fiction. So just answering question, there was a very interesting thing which had happened while we were doing our research. So there is a bit of humidity in Mars atmosphere, so which is kind of very less. In Earth, you usually have anywhere from 30% to even 80-90% of relative humidity. Mars atmosphere hardly has 1 to 2% relative humidity. But there were some concepts and studies done by NASA where they were trying to develop a material to absorb it and then use microwaves to release that. So that was also one kind of thing which had we had come across while doing a research, and then that triggered the idea that if you want to do this on Earth, you have abundant materials like that which can absorb water, but then you also have sunlight to heat it up. So, and there's a lot more relative humidity on Earth than on Mars.
So basically, NASA's research on Mars like led to you developing actually the same thing on Earth.
Yeah, you could say. And then like before this research has been done, I get a lot of inspiration from science fiction as well. So if you have seen Star Wars, there have been moisture evaporators on all across the entire universe, where the basic concept is that you take moisture from the air and then use it to for drinking or for your farms. So a lot of these desert planets, where one planet especially called Tatooine, where the whole franchise is set, and then the lead character grows up, has moisture evaporators all across the planet. So I think we are kind of approaching where the boundaries between science fiction and reality might blur out quite soon.
So would you say that let's watch more science fiction? But on a serious note, like, do you feel that watching science fiction actually maybe like leads you out of your like possibility wala zone, that you might feel that this is possible, this is impossible, but wo us line ko hi blur kar deta hai, and you start feeling like that everything can be possible, and that also leads to innovation?
Sure, because so what really happens with science fiction especially is it tries to create a more like a world where many things are possible. Like it might happen that you don't get the exact thing what you're trying to do. So maybe the water from air technology we are making is occupies a huge area of land. What they showed was just a small pipe kind of thing which is making hundreds of liters of water, which might not be possible even for next 100 years. But it tries to push you or gravitate you towards a possibility where things are possible, new innovations are possible, which might be even 50, 100, many years away. But then that sets humanity on the path that like you don't need to keep yourself back. There's a lot of inspiration, especially from these stories you can draw from and then implement in your real life.
This person right here with the right team has turned the impossible to possible and turned that science fiction into a reality today. So Swapnil, we'll go into the nitty-gritties of how you actually build this, but I really want to understand that why did you actually did this? Why did you actually converted say air to water? What was your inspiration behind it? And what's the name of this startup, as you call it, that's converting air to water?
Sure. So our startup is called as Uravu Labs. We are a Bangalore-based company. So to answer your question, like what led to this, we have to travel back to 2013. No, I am not that old. So I just turned 29 this year.
Okay.
So, but 2013 goes way back when I was in almost third year of my college. And we had just started working on an international competition called Imagine the Future of Water in Cities. So the concept of this competition was that you have to imagine futuristic solutions for water infrastructure for cities. So we took the city of Kochi in Kerala as our case study. So what had happened is, like, if you not just look at city of Kochi but many other cities in India all around the world, they're kind of based on a centralized grid infrastructure where you will have a treatment plant where water gets treated and then through pipes it gets distributed. But wherever this infrastructure doesn't reach, say out on the fringes of the city or even in rural areas, people usually rely on groundwater. And groundwater is a resource, is first of all rapidly depleting in many parts of the world. And it's also a non-renewable source. Why we call it non-renewable is because groundwater has been accumulating over billions of years. And it's not just rain falls and water gets accumulated. It takes many years. And on an average, by estimates, groundwater takes almost 1400 years to replenish naturally. So it's not gonna replenish within lifetimes or even my great grandchildren. So it's a resource which we have to use very wisely. So when we understood the city overall how it distributes water, we found that there were many gaps which could be filled with a more decentralized kind of infrastructure. So air came on top as a a good medium for us to draw that moisture and then use it.
How did you think of air?
So when we look at the concept of water from air, one other reason why we're looking at air as a resource, because water vapor in the air is almost 6 times the water we have in all the world's rivers combined. So you take all the rivers in the world, Ganges, Brahmaputra, even river Nile, Amazon, you take all the rivers in the world and multiply that volume by 6 is the amount of water in the air at any given point of time. So you can say there's atmospheric river flowing in the sky. And the good part is, because of the Earth's natural cycle, this water vapor gets replenished in just 8 to 10 days. So on the other hand, groundwater takes 1400 years to replenish naturally. You have a source like water vapor which just takes 8 to 10 days. So it becomes like an infinite source which currently we are not tapping. So Kerala has very high humidity. Okay, so there was always this issue that you're sweating all the time, and then I was kind of also irritated by how many times I have to take a bath on a daily basis. So like being a very humid, rich atmosphere, that was one research we thought like people are currently not using. Why not have proposed that as a solution? So we took that concept and we kind of went a bit crazy. We proposed that you can have hot air balloon kind of structures which are floating in the sky and drawing moisture, and there's a pipe from the sky to your house. So that was the idea we had.
Wow.
In 2013. So we just based on that idea we participated in competition. Nothing happened, we didn't get selected.
And what, like, when you presented that idea, what were the thoughts of people around you?
So it was more like like a jury kind of presentation plus a submission. So I wasn't able to gather a lot of ideas, but team was enthusiastic. My classmates were enthusiastic. They were like, cool. So yeah, we participated. Nothing happened, but then idea kind of got stuck that you can do something like that. Then in 2015, when I was almost in like last year of my college, what happened was there was there was a river which supplies us water to our campus, and our campus is in Calicut, almost 20 kilometers from the city. So we had to rely on this river water, and then during months of February to March, it got dried up because of the summer. So there was a lot of issues with water supply to our college. So there was a tanker which used to come every day, and we just used to get like 1 bucket per day per student. So that was the condition. Like just few months back you had like lots of water, and now suddenly you are just using 1 bucket per day. So that also kind of triggered kind of your necessary step, that okay, let's do something about it. And then we just started making crude prototypes of this initial idea we had of making water from air. So the very first prototype I remember what we made is we took a kind of a bag and we put a lot of ice in it, and we just left it in our rooms for many hours. So whatever moisture or water vapor in the air was there, it used to touch that cold surface, and you'll get some water droplets. So that was just a validation of like whenever water vapor strikes a very cold surface, you will get water droplets. So with that idea, we kind of thought, okay, this is doable, what we had initially thought in 2013. And then when I graduated in 2016, that was something I really thought we could work upon. So me and one of my co-founders, Venkatesh, we just started working on this idea, made some initial prototypes. We are not doing this full time, but we thought there could be something we can make out of it. Then in 2017, what also happened was I was part of one, I would say, a consortium of water experts from all around the world, and we had kind of visiting many places like parts in Rajasthan, Gujarat. And what we also saw in especially in Rajasthan and north of Gujarat, there's this Rann of Kutch belt where a lot of salt farming happens. So there what happens is like they will usually draw a lot of groundwater, and they will let this groundwater evaporate in these large salt pans. And you will have very small families, hamlets kind of thing. And there will be like 5-10 people at one spot, and then for another 10-15 kilometers there will be no one, then another set of families. And how they used to get water was whoever the company is who is then further processing these salts, they used to send water tankers every 7 to 15 days, and they'll used to just store it. So their water accessibility was a huge problem there. So even because they can't drink the groundwater because it's so salty. So but they have a lot of humidity, they have a lot of sun, but there's no water. So that again, like made me realize that water infrastructure is not what we take for granted in our cities. A lot of these off-grid areas, inaccessible areas, or could be because of the terrain as well. Say there's hilly areas, can't get water. So that again triggered, that whatever you're working on is a good way to, explore further and then do something. So, and then what was happened was again there were like two negatives against us. One was we were working in water. Other was we were doing a hardware. So, hardware necessarily takes more time, more money. So you wouldn't really get early stage investors there. Plus water was again something which, maybe universities could fund or some research departments would like to do, but not take a form of a startup as such. But we anyway, we didn't think too much, because I think sometimes if you think too much, you might not even end up, doing it. So we just kind of, dived into it. Then in 2018, I think that was a year where we actually, started seeing some good thing happening. So initially we had tried to develop this condensation based solution, but then we quickly realized it's not the most appropriate. A couple of reasons being that it's highly dependent on your relative humidity. So if it's a place like Chennai where relative humidity is 80%, you will get a decent amount of water at lower energy consumption. But as soon as you go to say, middle India or even desert places where RH conditions drop anywhere from 60 to even 30%, power consumption goes really high and you really won't get that much water output. So that was a big no in terms of water production. Plus, because of this reliance on electrical grid, it still meant that you're consuming lots of power as well as emitting a lot of carbon emissions, because still today 60 to 80% of our energy still comes from fossil powered power plants. So again, like we didn't wanted to make a sustainable technology which is on the other hand giving out more carbon emissions rather than like having a zero carbon emission. So then we shifted to a different kind of technology stack, which was based mostly on using desiccants. So what do desiccants do is they have very high affinity to absorb moisture from the air. So first we started using something called silica gel. So when you buy say footwear or pack of box of electronics, you will see a small pouch. So similar to that, now there are many other desiccants in liquid form as well. So we started using that, and the concept is pretty simple. Like you absorb moisture through that. So say you take 10 kgs of silica gel, in about 3 hours it will become around 12 kgs. That means it has absorbed 2 kgs of water. Yeah, so once silica gel has absorbed that, or any kind of once the desiccant has absorbed the moisture, we heat it up to about 70-80 degrees Celsius. So the 12 kg which was earlier then again becomes 10 kgs. So that means that water vapor is released almost in the form of steam, which we then thus condense at ambient temperatures to form fresh water. So the only energy input is coming from solar, and there will be a small set of fans and pumps which again can come from electricity from solar. So in that way we are able to make a zero waste, zero carbon kind of solution, which we can then through engineering also scale it up to deliver lots of water.
I think in your I saw a diagram I think on your website, उसमें कुछ mention था like पूरे structure में कहीं waste mention था. तो what is that waste?
Okay. So one thing what we do is we are comparing to technologies like reverse osmosis.
Okay.
So when we compare say reverse osmosis,
break down reverse osmosis please.
Sure. So reverse osmosis was a technology which was invented in 1950s, and it's a membrane based technology where usually what happens, you will apply a high pressure and only through that membrane then only water will just go out and other things kind of get held back. So reverse osmosis, what happens, it has become a kind of default technology for water purification, but it also wastes a lot of water. To make 1 liter of good water, you will waste almost 2.5 to 4 liters of water overall. So that means you have to draw more water from the ground. Plus all this water which gets rejected is either again going back to ground or you're to a drain. So it's kind of going back in a high TDS form with a lot of salts and other things in higher concentration. So we wanted also a solution which is zero waste, because in our case what's happening is water vapor is almost like the purest form of water in the air, and once you collect it we almost get demineralized water, and which you don't need to filter again. You just need to pass it through a UV disinfection if there is any microbial contamination. Otherwise it's as good as demineralized, very high quality water. So there is no wastage. So that's how we differentiate that. Compared to reverse osmosis, you're wasting so much water, but in our solution you're not wasting. So that's another way. And one other waste I think you would have read is maybe waste heat. So the waste heat concept is coming in the way that we need an energy source to heat up our desiccant. Now we have designed a technology architecture which remains flexible or even energy agnostic to the various heat sources. So solar is one option where we take heat from the sun and then directly use it to heat a desiccant. But we can also use waste heat from industries. So a lot of industries, say in the manufacturing space, process space, they have boilers, they have chimneys, there are many other processes where you will have heat coming out, and usually heat below 100 degrees Celsius is not put to use. Sometimes if you are heat at 150 or 200 degrees Celsius, it could be easily used for some other processes, but below 100 degrees is usually not put to use, and that's why I call it waste heat. But in our case, if there's an industry which is producing that kind of waste heat, what we can do is we can tap into that waste heat to heat our desiccant. So in that way, our solution is not just dependent on solar, but you can also intake waste heat and then use it to make 100% renewable water.
Great technology, like the kind of, the brains that you have put actually making every process literally sustainable. So, Swapnil, I want to ask from you that while on the outside it feels like, kya bana diya in logon ne, but on the inside, the journey you took. So, what would you say was the most difficult part of this journey, or was it very easy, like ho gaya bas ab to?
No, it was not at all easy, because like I had mentioned, a couple of things. One is you're working on water, which people don't really want to fund or don't see that as a problem. Second, you're also making hardware. And third was, you don't get that support from your friends and family. Also, if compared to this, say you're making something which is growing fast and, it's visibly growing fast.
In terms of revenue?
Not just in terms of revenue, could be any other traction. Nowadays is, okay, you have customers, you get funding, and you have maybe, business is running or team is growing. But then for the most part of our journey, like for say from 2017 till 2021, we were just 4 to 7 people. So your team is like you can sit in a room and then do it. And then funds for us were mostly through grants, or we were participants in some competition which we will win, and then we'll be getting that money. So bootstrapping was the main, I would say, the norm for us. That we won't be able to get access to a lot of private funds till a certain stage. And then other issues also that being a deep tech focused product, we also needed the team to have the right skill sets. So even if as innovators we'll do something, we can reach a certain stage, but then we also need more expertise to come in. And then that's how my other co-founders also joined us. So Dr. Pardeep Garg, he's a scholar from Indian Institute of Science, and he's also done his postdoc at MIT US. He was working on solar thermal energy and many similar products. Then Govinda Balaji, he's a mechanical engineer. Then he also did his master's in fabrication, advanced fabrication. So he knew how to then scale up these products, bring the right engineering, and from simulation to actual product. So these kind of things. So that's how in 2018 then 4 of us came together. Venkatesh, who I started with, is my batchmate from NIT Calicut, and so we thought now the team is more balanced. You have people from all kinds of things, but the main thing driving all of us was we have to do innovation, we have to do work something in the renewable space. and we try to draw a lot of parallel between what has happened in energy, and especially in renewable energy. So you would have solar, you would have wind, but then in the renewable water space nothing was happening. So that's the bridge I would say Uravu is trying to fill.
Did anything like in your journey particularly happen that you would say, where you felt like giving up, where you felt like kuch kyun nahi ho raha, and you felt like it was really hard? So was there any phase like that or any particular moment that you remember?
I think there were many such moments. So in 2018, we had got we were a finalist in this competition called Water Abundance X Prize. So X Prize is a LA-based foundation, and they do these multi-million-dollar competitions every year. And that year, they were doing something on make water from air using renewable energy. So that was like the sweet spot we were working on. So we got around $50,000 grant, and that was like a big, I would say, motivator for us to keep on working. So we thought, okay, no more bootstrapping, let's do it and do it properly. So we hired more people, and then we started working. But then those funds dried up, like in, I would say, 9 months or 12 months. And then suddenly we were kind of in a pickle, what to do. And then some grants will come, but then, the problem with grants is either the amount will be too small, or it will come in between a gap of 6 to 9 months. So the wheel of innovation doesn't take a full turn. It turns a bit, and then it stops, and then you have to wait, then it turns a bit. So in 2020, then again COVID came. So COVID was a big blow for us, because one is, as a hardware company, we can't really do work from home. So then the team got kind of dispersed, everyone went home. So a couple of months there was like nothing really happening, and we also thought, like, should we give up, or should we continue? But then we thought, okay, now is not the time to give up, because we were getting some kind of traction, in the sense, there were some corporates who were interested. There were some strategic buyers, I would say, that who were kind of looking at new solutions, and they were also interested. But then interest doesn't necessarily mean that it would be a success. But then still, being an entrepreneur, you have to, I think, even there's a last strand of hope, you will still cling to it. So we thought, no, let's not give up. And then we are making actually good progress, be it slow, but it was good.
It's progress.
So then, say somewhere around late 2020, we kind of found a strategic investor. They were working in the solar space, and maybe not like they're not a private investor, but then we thought, for a technology like us, or for a space like us, this could be a good value addition overall. So we had started our conversations, had many sets of discussions, and it was almost, they had finalized that they will do an investment. But then later, I would say at the last stage, they pulled out the deal, and then like we couldn't progress further. So then we also had to let go of our team. There were some employees, almost 4-5 employees were there, so that we had to let go. And then whatever progress we had thought would be kick-started again, or move forward, because of this funding, that we couldn't do. So that was like a big setback for us. So I would say that was a really low point for everyone. There were moments where I wouldn't want to get out of my bed, because again, because I have heard no so many times, the fear of disappointment again and again and again. So I would say, I think February 2021 was like the worst months for me in the last, or my entire life, I mean.
Why would you say so?
Because of such things, right? Like, because you have worked good 3-4 years on something, and you don't want it to die, and but then you get some ray of hope, and things start moving, then but you again get back to square one, or even worse. So, and then there was also a moment when I had to ask employees to leave, because like we were just, as I said, just 6-7 people, and then you get so close to everyone. They're not employees anymore, they're almost like friends. And so it's become really hard to tell people that like nothing's gonna happen, and we might have to let you go, but we'll compensate in some way or the other, so please trust us. So building that, so the trust gets broken, but then you don't want it to fully break, and then keep that in place.
कभी कभी अंदर से भी ट्रस्ट नहीं आ रहा होता कि उनको तो बोल रहे हैं कि ट्रस्ट अस, बट will I be able to even like do this? Like it's a good cause, but how it's gonna happen? Swapnil, like I want to ask you this thing that अगर आज इस situation में you have to go back वो February 2021 वाले Swapnil के पास, what would you tell that person today?
So I think what I will tell him, which I tell today also whenever situation gets tough, is that you have to persevere, because there is something which, like the bigger cause which you really want to work towards. And then I think I would just tell him to be bit more patient and bit more thankful to other things in your life, because sometimes what happens, being working on just one thing or being focused too much on work, you think that your whole life revolves around that. But then you sometimes you have friends, you have family, which you might go further for support, which I didn't realize at that time, that like they have been there in their own ways. But then sometimes if you keep them closer, especially during such times, it would have been a lot easier.
Do you think today you are fulfilling your version of success, the version of success that you as a person have in your mind?
Okay. So I think I'm on the right path, but kind of there's a lot more to be done, and a lot more to achieve overall. So overall, just not personally, but even from Uravu's growth side, I see that a lot more to be done. We have just started doing early pilots, and some commercial traction is going on. But then how do we solve this big challenge of water access overall, and maybe not just for communities, but also for industries. So, and how do we get to that scale?
And how do you think that, and why do you think that your say solution or your product is relevant to industries?
Sure. So when we were started working, one thing we realized was cost is going to be one key element of our solution, because water, if you look at as a commodity overall, either it's almost free, like people will just dig bore wells and just start drawing water, or it will be subsidized heavily by the government. So even if you pay 10 to 15 paise per liter for your water which comes out of tap, that water actually costs a lot more, because government has to put a lot of this infrastructure to treat that water, distribute that water. So if you just take example of Bangalore, we get water from river Kaveri, which is almost 200 kilometers away. So it's not a small feat to distribute water from 200 kilometers and then to so many houses. So but we get water at a subsidized rate. So like when you start, say a new solution comes out, say what happened with solar PV 15-20 years back, it was way costlier than say coal powered power plants or grid electricity at that time. So similarly with water, we thought there will be a price increase there, or we can say there will be a green premium to it, but then it can't be too much, because still at the end of the day, water being a commodity which goes in almost every process or product, or even for human consumption. So scalability was definitely one element which we had in mind. So we came up with a more, I would say, a decoupled kind of design, where a desiccant unit which does the absorption desorption is a separate module, and an energy unit is a separate module, and they are just connected by a fluid media which enables the heat transfer. So what has happened was this desiccant unit can be then customized to suit any volume requirements. So say you want 2000 liters or 10,000 liters per day, we can make a single customized unit which can enable that kind of absorption desorption, and then the energy unit could be a separate unit that can scale accordingly. So if it's a small solution, the energy unit will be a small set of panels, but if you have more water requirement, the energy unit will also grow accordingly, or rather parallelly. So because of this kind of scalability, we can take advantage of economies of scale, bring the cost really down, and then address larger volume needs. So that's why we think industrial needs, especially if they're relying on depleting groundwater, this could be a lot more sustainable solution for them.
And while building, say, a sustainable business, like environmentally sustainable business, how do you build a sustainable business model also? Like, how do you ensure, say, profits coming in, revenue coming in?
Yeah. So that's like it's also a bit tricky. Sometimes what happens is again just
And like, let me just add to that question one more thing. When you were building this technology, did you had a revenue model in your mind? Did you know how you as a team, or like you all as a team, are going to monetize this?
so I would say like this was also a big journey for us. Like really locking down on our niche and figuring out where do we want to play in that spectrum, because like if you're playing this whole game, you better play to win, right? So that was like a big exercise for us. When we had initially started, we were really thinking that we'll be able to make it at such a low price point that we can serve bottom of the pyramid market, like go to every village. So I in my head there was this number goes on that India has 6 lakh villages. Even if 10% villages don't have water, there's a big market for us. So but then what happens is, like when we actually build this solution, you take into cost of R&D, manufacturing, everything, plus you have to add profit margins on top, but we see that there's a premium which has to be paid out. We can't supply water at 10, 20, 50 paise per liter. So our water would be like say 3, 4, 5 rupees per liter. So then we have to find a certain niche which can absorb that premium, at least initially, till we are say 5, 10 years out, and it's as affordable as possible. So we locked down on the beverage industry. So why beverage industry? One is it consumes a lot of groundwater. Overall, the beverage industry consumes almost 1500 billion liters of water, and almost 45 to 50% is coming from groundwater sources. So it's a huge amount of water consumption, which currently they are relying on a non-renewable depleting source. But almost 90% in most beverages is water. So that became like a niche, where we can target. And overall, the beverage industry almost a $2 trillion market. So here also, what we thought is, instead of going into say mass beverages, which require a lot of scale, a lot of water, let's just focus on say premium beverage products, craft products, or rather just alcoholic products. So what happens is, say you buy a bottle of beer, which is almost 200 rupees, and then the amount of water in that will be hardly 650 ml to up to 1 liter. So now even if you replace that water with a water which is 2-3 rupees more, your 200 rupee bottle with added margins might become 205 or 210. So that's not a very big difference in the premium any consumer is paying, and beverage companies could also pass that cost to these consumers. So that was the idea, that how do you find a product category, or rather an industry, where this cost seems less overall. So beverage industry really fits that. So beer is just one example. If you take say liquor products, whiskey, gin, nowadays these bottles are available at even 1500 to 2000 rupees, and if you add water cost of 2-3 rupee extra, it's gonna get hidden. But for beverage industries, there are two value additions. One is on the back end, they are saving lots of groundwater, which they would have like either depleted or used excessively. So they are trying to address some of their sustainability goals. And from the consumer side, it also gives them a marketing tool in their kitty. So now water or a beverage is a tangible, water in that is a very tangible thing. So once you hold a bottle of beer which is made with renewable water, you can also market it in a way that it's a sustainable beer made from air. So it's also a marketing tool for them. So I would say kind of becomes like a win-win for beverage industry, for us, for consumers. So beverage industry kind of became a target market. But then we're also looking at some corporates who are trying to eliminate plastic bottles on their campus. So instead of using small plastic bottles from many companies, what they want to do is put a unit, generate water on site, and then fill in refillable bottles. So then also creates they reduce plastic waste, and the water would have come from groundwater, maybe from 100 kilometers away. So you save a lot of the groundwater, you save a lot of the transportation cost, and all the emissions, CO2 emissions related to that. So in that way, it becomes more sustainable for us, for the clients, for the planet.
And it's very, like, I think thought provoking actually, the way you're solving that problem. For example, like I personally, I think I wouldn't have thought about that the water coming from beverage is what source it is coming from, and then making that source also renewable. Like that requires a very deep thought process into, like, I am myself like, wow, like, my god, this is happening. So I want to ask from you that one case scenario you gave of beverage industry, one you gave, say, for corporate. So when you first pitched the idea to, say, any XYZ beverage industry, what were the initial responses? Like, was there something surprising, or what was that?
So I think overall the response has been quite positive. So what has happened with many beverage companies, they have been also been, I would say, a victim of their own processes, of their own way they operate. So just to cite one incident, there was a Coca-Cola plant in Kerala, and it was you used to withdraw almost 1 million liters of groundwater every day.
Every day?
Every day. So that's like 10 lakh liters of water every day. And I think it was in Palakkad in Kerala. So what had happened was, after a few years of operations, the local groundwater wells and tables had deteriorated really low. Plus there was also like a lot of contamination which happened in the groundwater. So it started affecting a lot of local communities, farmers in and around that factory. So then because of these protests and all, they had to close down. There was like a big case, and then they had to close down that plant, and they also had to pay some $30 million in compensation to the local communities. Now, just to give you the comparison, if they would have installed Uravu's solution, they could have spent, say, almost the same amount in compensation which they paid for Uravu's solution, but they would have saved that 1 million liters of groundwater every day, and rather more, because reverse osmosis again wastes a lot of water, so they're almost withdrawing double than what they need. So in just like $15 million, they could have installed Uravu's solution, not affected the local communities, had their factories running for many years, and like in the same amount of investment, they would have not even tarnished their brand. So for a lot of these beverage companies, brand is kind of very high value to them.
So, beverage industry, like, you gave one use case scenario, and it's surprising, and also like the impact that your solution could have on the groundwater, and like, it's crazy when you think those numbers, right? So what are the other use case scenarios you feel that Uravu's product or Uravu can solve?
Sure, definitely. So as I said, like, beverage is just our first initial target areas, and what happens is, say, beverage industry is overall your addressable market is 1500 billion liters, but as soon as you go a 1 rupee even lesser, say we are at 3 rupees with beverage industry, you go 1 rupee lesser, say at 2 rupees or even 1.5 rupees, then this addressable market starts including a lot more use cases. Now your pharmaceutical industry could also come, because nowadays any product which doesn't need to then pass that cost further starts coming in. It could be some premium footwear, clothing. They also use lots of water. Then it starts also addressing a lot of their drinking water issues.
And all the water that they use is fresh water.
A lot of that is fresh water. Okay. Because like, just to cite examples, a pair of jeans takes more than 1500 liters of water, excluding cotton and all those things, which again becomes like a footprint from the overall supply chain. But then as you keep on reducing that cost, say now you come to 1 rupee per liter, then all that bottom of the pyramid market, which is almost consuming more than 1 trillion liters of water on a per day basis, again, who are not able to access water, or women are walking a lot many hours to collect that water. You have villages in Africa, you have parts in India. So just in India itself, there are almost 160 million people, all out of the 1300 million people, who have water stress, severe water stress. So either they're relying on some old hand pump which gives water only for once a day, or they're relying on tanker water, or you have to walk for like many kilometers. So according to UN data, women are spending for the to and fro collecting water and then coming back more than 60 minutes on an average per day. So many women doing that also means they're not able to do some economic activities they could have done with that 1 to 2 hours. Plus there is because of the bad water quality, a lot of waterborne diseases happen. So like 5 million kids die every year because of waterborne diseases. So if we're able to solve that as well, that saves a lot of shadow cost. So that's the term we use, that there's a shadow cost associated with having bad quality or less access to water, because your economic time which you could have spent there, your medical bills, the extra wage you could have earned, so all those things, if you keep adding up, the true cost of water is not 10 paise, 50 paise, it's
It's a lot more. So today, what are the areas that your products are installed in, or like at the current situation?
sure. So currently most of the installations are now with beverage industry, where we have installed some units in Bangalore. Now we are installing some units in Uttar Pradesh, and then we are going to install some units in Delhi as well. So that's more with the corporates, institutional sector.
And what would you say, like, do you have a number, a rough estimate that you could say that, okay, we have, say, saved this much amount of groundwater?
Sure. So one metric we try to track is the installed capacity. So say if you have installed a capacity of 100 liters per day, then on an equivalent we would be saving almost 200 liters per day of groundwater. So right now, including the units we have at our office plus what we've installed, we would have an installed capacity of almost 50 liters per day as of today. So we are saving almost 100 liters per day of groundwater.
100 liters per day. You know, Swapnil, that I read about the technology, I heard about it like when we connected, obviously. But talking to you, it just makes me realize the impact that this technology can have at a scale. And I really, really, really want that this to scale and people to genuinely, to use it if they have to do something of that kind, because it's the kind of impact it's creating for everyone. It's crazy. It's crazy. My last question to you would be, while you were doing research, like, there is a lot of chaos always happening around us. While we have a moment to celebrate, there would be another moment waiting for us to, like, literally punch us in our head. So during that moment, how do you keep yourself focused? Because in your case, research has an extreme importance, like, at least when you were developing this product. And उस टाइम पे ऐसा था कि सब कुछ, like, everything was just very smooth, and if it was not smooth, how did you actually kept yourself focused on the research what you were doing?
So I think we do a lot of things by trial and error. So what happens is, there's one way that you make a lot of simulation models and then you try it out, but usually the reality would be a lot more different. So we try to do these rapid prototyping and experiments. So even if you're going to go wrong as soon as possible, like, rather than doing your simulations for 1 week, then speculating, can my simulations get perfect to a point where there are no issues. So that usually doesn't give you the right results. So we try to experiment a lot. So from the calm state we go into firefight state, where all these experiments will happen. Sometimes we work on, even today, sometimes we'll be working on Sundays as well. So we do work on Saturdays is not off, but we sometimes work on Sundays as well. So I think focus comes from 2-3 aspects. One is like, you want something to happen and there's a deadline to it, like not just say internal deadline, but could also be customer related, it could be supply chain related. If you don't do this today, the opportunity to order that component from the vendor goes away by 2 days. That means your thing is going to come after 2 weeks rather than just in 7 days. So many aspects keep happening like that. And the big motivator is again that you're building a solution which is going to impact the world, which is going to impact a lot of people, starting with say a few industries, but then the scale of which is the world is wide open. The amount of water required, especially our fresh water, and especially something which goes into the human body for consumption, where quality is very important, reliability is very important. So I think that's a big motivator overall.
And like, what would be like one thing that you would say, or maybe anything that you would say, like you would have really, appreciated someone telling to you those words maybe when you were just starting out? Or for example, let's just to rephrase it, if there is someone who is like the 23 or 24-year Swapnil, what would you say to that person today?
So I think what happens is, when we were like growing up, and when you're say in your early 15s, you just become a teenager, you will be having these lot of wild ideas. Like, I'm talking about myself, but there were still many people who have wild ideas. Sometimes they want to do many things which kind of break the norm, and sometimes our parents or some other relatives might tell you, don't do this, don't do that. But I think you have to balance out a couple of things. One is, you don't have to be doing something which some other people are telling, but some things you have a heart in, but then you also should have some amount of capability to do also those things. And where you think you're lacking capability, you should be humble enough to learn that, or bring in people who can help you that, and be open to learning. Because if you stop learning, and if if you stop being a student, I think that's when you start thinking that like nothing can affect me, this is the right path for me. You stop listening to people. So I think having that element of always learning, always being curious about things, and having faith in that if you do things the right way, and if your heart is in the right place, things eventually could turn up good. Because even if you fail, but then you wouldn't regret that you didn't put that effort, or you weren't focused, or you weren't aligned.
How many times have you failed?
Wow. Like depends on the definition of failure, but I would say many times. Like personal failures, sometimes, like even if you're disappointing your team member, sometimes that's also a failure. So
give me some instances that you thought were failure.
So sometimes we would have had conversations going on where say with investors, things would go really good, but then for maybe reasons which we don't know, but then things won't happen or materialize. So personally, I would have felt failure in many moments. Then sometimes it also happens, like you promise something to an employee. So when we didn't have too much projection on our funds, we would have promised that in 6 months we'll increase your salary, please stay with us. But then in 6 months that wouldn't happen, and then that would be a big failure, because personally you're not able to fulfill that promise, and in front of your teammate or employee also, you think that he is now thinking, no, this guy is not reliable, do I still continue working with him or not? So I think these are the kind of failures which really happen in early stage. Nowadays failures are more like operationally this is not happening, why is it not happening, this was supposed to be done 2 days back, why is it getting delayed? So it still depends on like varies from person to person. So like say for some people, even if you're not able to get back to a person on the same day, people might think it's a failure, or you're not working hard enough. So I think sometimes you have to take less stress, and mentally keep yourself sane, talk to people.
Definitely. So thank you, Swapnil. Thank you for being with us, and thank you for building something which has such a greater impact. I always say this, that I know the journey wasn't easy. Going forward, the journey will not be easy, but still, you are at it. You're taking every challenge and not stopping. So thank you for doing that, and thank you for paving the way for many more people who are going to build or who are building things for impact. Thank you for being with us today.
Thank you so much, Shweta. Thank you for having me.